This part we already know and we have discussed it so many times that whenever we have a vector, right? So
Yes, sir.
its magnitude is given and the angle is given, angle with the horizontal, right? So we can write this vector as how we can write this vector?
Um, Sine cos theta.
Yes. So how do we write in the vector form? Absolutely right. So you already know that this is a cos theta, right? And this is a y, right? A sin
Yes, sir.
theta. Okay, yes, it has. So you know that this is in the x direction. So what would be the direction? Yeah,
A cos theta y, A plus B sine theta.
yeah. But what is the direction of this part?
I cap.
I guess yes. And then we have a sin theta and g. So this is how we do the resolution of vector, right?
Yes, sir.
So we have done so many questions and you have forgotten what's happening. So let's say that let's say that a force is acting on this direction, which is let's say 20 Newton, and the angle is 60 degrees. So how can we write this force? Okay, so Yasir came and then he left.
Yes, sir. No
Yes, what
problem.
would be the force? Yeah, I just did. Yeah, what would be the force?
Sir, first we have to take whole root, right? A square plus
Whole
B
root.
square plus 2ab cos theta.
So a square plus b square plus 2ab cos theta, that is the resultant of two
I.
vectors. Yeah,
Yes, sir.
whenever we have this kind of A and B vector and then angle is theta, then we talk about the resultant, which is which is right.
Yes, sir.
This is the resultant. But we are talking about the resolution of a vector. So then,
Yes, sir.
just like this, we have a magnitude 20 and cos 60. This would be this component, right? Horizontal component. 20
Yes, sir.
cos 60. And this would be how much? The vertical part?
Um, what can we, sir? What should we write here? Vertical part. You didn't give any value,
Yeah, so
right?
that so I have already given this magnitude, right? And
Yes,
this
sir.
angle. Yeah, so what would be the this vertical part? This is the vertical part,
Um,
right? This is the horizontal, this is the vertical part. So what is the magnitude that we have? Yes.
Magnitude
What is the
20 cos
magnitude?
theta. Oh, 20,
Magnitude
20
is only
Newton.
20, right? And then sine of what is the angle? 60.
60 degree.
Yeah. This is the vertical part and this is the horizontal part. Just like this. So this would be 20 cos 60 I hat and then what? Yeah. And then
Then 20 sine 60 J cap.
yes. So this is what we call the resolution of it. So always remember this. This is very important. Okay.
Yes, sir.
And then we have this three-dimensional coordinate system. So we have x, y, and z, and then we have a vector, right? R,
Yes, sir.
and this is let's say R, or let me write it as okay. And this is making an angle A. So this is the coordinate of point, right? So
Yes, sir.
so this is making an angle alpha with x, and it is making an angle
Beta with y.
beta with y, yes,
Gamma
and
with
gamma with z.
Z.
So then we talk about the direction cosine.
Yes, sir.
So direction cosine is, let's say, cos alpha. So this is simply ax by. And then we have cos beta. So this is simply ay by. And then we have cos gamma. This is y. These are the directions.
Yes, sir.
And then we have a special property of this direction. That cos square alpha plus cos square theta plus cos square gamma is how much? Yes, since we have proved.
How much?
Yeah.
Cos square? Alpha plus beta plus gamma?
Yeah. Yeah.
Sir, can we take common outside?
So this is this is an operator. This is not a multiplication, right? Cos this is not a multiplication. Because do you write cos A plus B as cos A plus cos B?
No,
Right.
sir.
This is not right because this is a trigonometric operation. So
Ah,
cannot. So yeah. So just recall this is one. Okay. And we have approved this also in the class.
yes, sir.
So yeah.
We'll plus
Okay.
this
So this.
all, then square it, then we'll remove a
Yeah.
square. Then
Yeah.
when we'll add all of them, then we'll get a square. Then a square will cancel, then we'll get 1.
Yeah, absolutely correct. So we will get ax square plus ay square plus az square, and this is how much? This is a square.
A.
That is how, yeah, that is how this will cancel out and yes, correct. Yeah, so many days, everyone is absent.
Yes, sir. Sir, someone new came.
Yeah. Yeah. Yes, hello Siddhika. Assalamu alaikum.
Walaikum salam, sir.
So you missed the previous 2 classes, right? You were not there. And
Yes, sir.
yeah, what happened? Enjoying the holidays or there were some
Sir,
problems?
we're going to shift houses soon, so I've been a
Oh,
bit busy.
oh, okay. Okay. So yeah, because everybody is so many people are absent. This class. That's why we may have some problems, right? Otherwise, I would be always repeating all these things that I have. So we will be
Yes, sir.
stuck at the point. That is why, yeah, please be there. Okay, but so we already discussed this resolution of vector, right? Resolution of a vector, yeah. So let me just quickly repeat for you, Stika, that whenever we have a vector, right, and its magnitude is given and its angle is given, so we can break this vector in 2 parts, right? This is called the rectangular coordinate, right? So we can break this vector in 2 parts. One would be the horizontal part and the other one would be the vertical part. So the horizontal part is a cos theta and vertical part is a sin. So we can write this vector in the Cartesian form as well. So this is the horizontal part and this. So this you already know, right?
Sir.
So let's say that we have a vector whose magnitude is 20 Newton, right? Whose force, we have a force whose magnitude is 20 Newton, and it is making an angle 60 degree with the horizontal. So what we can do is that we can write this force as this one, because this is the horizontal part, and then this one, the vertical part. Okay.
Yes, sir.
Yeah. So this we did in the two coordinates, right? X and Y. But whenever we have three coordinates, then how can we resolve the vectors? So whenever we have three coordinates, right?
Sir, someone new again came.
Yeah. No. Yeah. Hello, Martin. Hello, Martin. Yeah. Hello, Martin. Hi. Can you hear me? Because your voice appeared very faint. So
Okay, now.
yeah. Yes. Hello. Okay, so now what happens that we have a three coordinate system, right? And then how do we resolve the vector? So we have this vector whose x component, y component, and z component are this. So then we write, and also this is making an angle alpha with the x coordinate, and it is making an angle beta with the y coordinate and gamma with the z coordinate. So then we talk about the direction cosine, right? And this direction cosine, so cos alpha is ax by a, cos alpha, and cos beta is ay by a, and cos gamma is by a. So these are the relation for the direction cosine. And then we have this peculiar property of this direction cosine. So when we square all the direction cosine and add them up, so that will give us 1. Okay, so this is the basic concept we need to solve further questions. So okay, so let us do some question, right? And if you guys have a problem with some concept, so you guys can ask. Okay.
Yes, sir.
This we did in the previous class. This question I gave as homework so many times, but nobody sent me the answer, so I did. Okay. This we did in the previous. Now let us do this question. Okay, so yesterday was a fortnightly test. So who attended that? So how many of you guys have
I
taken
was
that?
not able to attend, sir. I was
Oh,
outside
you were not there. So
and
and
I was sick.
yeah, and Siddhika and Martin, what about you guys?
Sir, I wasn't in it either.
Okay, you were also not there.
No, sir. I was out of the city.
Oh, okay. And Martin, what about you?
Yeah, what are you asking, like class or something?
Yeah, so yesterday we had a test, right?
Oh, okay.
Yeah, that
I didn't.
fortnight. So you were also not there. What I will do is that I will discuss the question paper at some point later. But yeah, you guys see that school will be reopening. Not soon, but we have 1 month and a few days. And we want to cover so many of chapters. So guys, please be punctual. Okay. Okay, so this is the question, and this is totally based on the resolution of vectors. So we have three vectors, right? And can we get the resultant of three vectors using the parallelograms law? Yeah. So can we get the resultant of three vectors using the parallelograms law? Okay.
Sorry, sir.
Yeah. So can we get the resultant of three vectors using the parallelograms? Yes. Hello, Yasir. Hello, Yasir. Hi. You came and then you got disconnected somehow. Maybe some international issues. Okay. Okay. So who got disconnected? Yes. Akif, my voice is lagging. Am I audible now? Am I clear now? Yeah. Uh, hello. Am I audible now?
Yes, sir.
Okay. So I am
Your voice is clear.
okay. So what I am saying that in parallelograms law we have how many vectors? So we have only two vectors, right? Let's say this A and this B, and then we draw the parallelogram, right? And this diagonal gives us the result. This is A plus, right? So whenever we have two vectors, then we use the parallelogram law. But we have three vectors here, so we can't use the parallelogram law to get our result, right? And we can solve numerous problem whenever we have this kind of vectors. So whenever we have a vector in the Cartesian form, then we can add, we can subtract so many of the vectors. Right. Let's say P is some Pxi, Pyj, Zk, and then T, and then T. So we can add, we can subtract, we can do whatever whenever we have a vector in this Cartesian form or in this rectangular form, right? But we can't apply the parallelograms law whenever we have more than two vectors. Is this clear to you guys? Yes. Clear, guys?
Yes, sir.
Yeah. And how do we reach this Cartesian form? So whenever this kind of form is given, so we can apply the resolution of vector. So that is why this resolution of vectors comes in handy whenever we have this kind of form, right? The magnitude is given and the angle is given. So then we use the resolution of vector and then we break the vector into parts, right? So we have only x and y, so we will only break this vector into parts. This part is okay. So now this is clear. Now let us use the resolution of vector concept and then solve this problem. Yeah. So Yasir, this was your homework, right? So did you solve this part, Yasir? Yes, Yasir. Did you solve this part? Okay. So if you have not solved this part, so yeah, let's look, and if you have solved this, so just check. So the magnitude of vectors OA, OB, and OC, right? So we have x and this y coordinate, and this is A vector, right? And this is OC vector, and then we have this. Then we have this OB vector. Okay, and this angle is 30. This angle is 60. And this angle is 45. Okay. So just remember this, that whenever, let's say we are moving in x direction, let's say 3 units or whatever units. So this would be right. So this would be what? This would be ax, and this would be ay, which is right. And this is the angle. So the vector is AXI and AY, what? AYJ. Okay. So if we want to now see that you guys see that this theta is not given. If theta is not given, so we can calculate tan theta as what? Tan theta would be how much? Yeah, Siddhika, can you please tell tan theta would be how much? So let's assume this triangle, right angle triangle, right? This is the theta, this is the hypotenuse, this is base, and this is perpendicular. So what would be tan theta? Perpendicular by base, right? Which is AY by. So yeah, so yeah, so this would be the theta. Okay. So whenever the x and y component is given and they want us to calculate this theta, so you just divide the y component and x component. So yeah, we will come to this point later. So, but before we come to that point, let us. Okay, so the magnitude, what is given? The magnitude of vectors OA, OB, and OC in the given figure are equal. Right, so magnitude of OA, magnitude of OB, and magnitude of OC is equal. Let's say this magnitude is, let's say, K, right, K magnitude. Let's say 3, 4, 5, or whatever is this number. So let's say that this is K, this is K, and this is K, right? So what I talked about earlier, the resolution of vector, right? We have some magnitude, and then we have some angle. Then we can write the vector, right, in the Cartesian form. So OA magnitude is K, right? And the angle is 30 degrees. Okay. So you guys tell me that what would be the OA vector? Yeah. What would be OA vector? So Siddhika, tell me what would be OA vector? Yes.
Cos
Yeah.
theta,
Yeah, but cos theta is
cos
correct. But
30
what?
theta
Yes.
plus
Cos 30,
sin
but we have magnitude. Yes, yes.
I
Correct,
mac
correct. You
I
are.
cap cos 30 degree I cap plus sin 30 degree J cap.
Yeah, but what about the magnitude? So this is the magnitude, right? K is the magnitude. Yeah, you are absolutely correct, but just one missing part.
Oh, okay.
So K cos theta. This is the right. We have this magnitude K. So this part, right? This part would be K cos 30, right?
Yes, sir.
So K cos 30. Yeah, you are correct. K cos 30 I cap, and then K sine 30 G. Yes, good. So this is OA. Okay. And yeah, Martin, you tell me that what would be OC vector? Yeah. Just one point to remember that OC vector is this part. So this is the vertical part, and this is the horizontal part. So just remember, for OC we have this part horizontal and this part vertical. So Martin, what is OC vector?
Root 3 by 2.
By 2. Where does this 3 by 2 come?
Root 3 by 2, right?
No. I am asking about OC vector. This OC vector. We will solve this further, but first let us write. Yeah. Yes, Martin. So what would be
Yeah.
OC?
So like OC is K sine
First is the cos part, right? So K cos, and what is the angle?
45.
So K cos 45. But we have important thing to remember here. What is the direction of the horizontal part? Yeah, this is x, and this is what? So this is, if this is I, so this is what?
K J.
J is this. J is y.
Oh, so then it's I.
Yeah, this is I, so this would be what?
I.
We have talked about different kind of vectors, right? So negative vectors, opposite vectors. Does this link any value? Yes, Akib, you tell me what would be the direction? Yes, Akib. Yasir. Yasir, what would be the direction? Okay, so Siddhika,
Yes, sir.
what would be the direction? This is in this direction. So what would be this direction? Minus I. Yeah, yes, correct. Yeah. So minus I. Right, guys. So if this is I, so this is a negative vector or opposite vector. So this would be minus I. Right. Okay, yes, correct. Yeah. And then we will have K sine 45 and J because this is in the positive J direction. Okay. And then what do we have? We have OB. So Akif, you tell me that what is OB vector. So remember that OB is this. So what is OB vector? Akif. So first try and then tell. So first try. What is the magnitude of OB? Yeah. What is the magnitude of OB? Magnitude is K. Magnitude is K, right? So K, and this part is cos. So K cos 60, and direction is what? I have. This is the horizontal form. Okay, we have this vector, which is this angle, which is 60 degree, and this vector whose magnitude is K. So this would be the horizontal part, right? Let's say AX, which is K cos 60, and this is AY, vertical part, which is K sine 60, right? So this would be K sine of 60, and what would be the direction? So this is J, so this would be what direction? Yes, we just discussed. So what would be the direction? Okay. Yes, what would be the direction? Yeah, J or minus J. See, this is J, And this is the vertical part of this vector. Okay, so you guys are getting, that is why I'm saying that you guys please be ready. So this is yes, minus 2 minus. It's correct. Yes, it's correct. Okay, so this is minus 2. Okay, now we have calculated all the vectors, right? Now we have calculated all the vectors in which form? In the Cartesian form. So in the I and J form, right? So that we can find what is this vector. So first, let us simplify this. So this is minus of k cos 45 minus of k cos 45 I and k sin 45 g. And this is how much? This is k cos 60 I minus k sin 60 g. So what we need to find out? We need to find out the direction of OA plus OB minus. So first we need to find out what is the vector. OA plus OB and minus. So we have to find this one. So let us find this one. So OA plus OB minus OC would be how much? OA is k cos 30 I plus k sin 30 j, and then OB. So OB
Sir?
is, yes.
Shouldn't we find their values first?
Yeah, I will. So this part I have just kept as it is. I will just simplify them, right? Because otherwise I will have to. Yeah.
Okay, sir.
Yeah. There will be so many numbers. Then yeah, there will be mix-ups. That is why I have kept this 4 letters, right? OB.
Yes, sir.
Yeah. And K. Where was that? So plus K cos 60 I minus of k sin 60. And then we have minus of minus k cos 45 and I plus k sin 45. So these are the vectors, right? So this would be ours. This is k cos 30 I plus k sin 30 j plus k cos 60 I minus k sin 60 j plus of k cos 45 I and minus of k sin 45 j. Now as simplified. So let us simplify. Cos 30 is how much? Yes. Cos 30 is how much, guys?
3 root square by 2.
3 root square or root 3 by 2.
Root 3 by 2.
And sin 30 is how much? So just the opposite, simply 1 by 2. Right. And then we have cos 60, which is 1 by 2. And then sin 60, which is 3 by 2. And then cos 45, which is 1 by root 2. And then again sin 45, 1 by 2. So these are the numbers. Okay. So we can write, this is in the denominator. So what we can do is that we can put this in the numerator. So this would be k root 3 by 2 I plus k by 2 j plus k by 2 I minus k root 3 by 2 j and then plus k and multiply by root 2 and divide by root. So this would be k root 2 by 2 I and then minus of k by 2j. Okay. Then what we do is that, so that is why we have changed this in the Cartesian form, because addition with I is so k root 3 and k and k plus k by 2 plus k root 2 by 2 I, and then k by 2 minus k root 3 by 2 and minus k root 2 by 2. So you guys see that. What do we have? We have, let's say this is ax and this is ay. Right. So this is OA plus OB minus. So this we have calculated. Now in the question they are saying what? So first part was calculating this result, whatever these vectors. And then secondly, they want us to calculate that the direction of this vector with x-axis, right? So we have a vector which is OA plus OB minus 2, right? So this has some, let's say, AY part and AX part, right? This is AXI, this is AXI, and this is AY. So we know AY, we know J, and in the question they have asked that what is the direction with this XI. So they want us to calculate this term. Right, guys? So what do we know? We know that tan theta would be how much? Yes, Martin. Tan theta would be how much?
Tan theta.
Yeah, tan theta would be how much? Yes, Martin, what did you say?
OA
You,
plus OB minus OC. Okay, AY by AX.
yeah, AY by AX. Right, because this is the perpendicular, this is the base. So tan theta is simply AY by AX. Right. Now, the same concept we have to apply here. So we know what is the horizontal component, right? And what is the vertical component. So we can calculate the angle with the horizontal as AY by AX. So AY is how much? AY is K by 2 minus K by 2 minus K 2 by 2, right? This is my AY, and AX is how much? K root 3 by 2 plus K by 2 plus K root 2 by 2. So this is my AX. And what is common here? So K is common and by 2 is common. So I can take K by 2 outside, and this would be 1 minus 2, 3 minus 2, 2. And again, from here I can take K by 2 common. So this would be 2, 3 plus 1 plus 2. So K by 2 cancels, and we can arrange this to minus 1 minus 2 minus 2. And this is 1 plus 2, 2 plus 2. So the theta angle would be tan inverse, and 1 minus 2, 3 minus 2, 2 divided by 1 plus. So this is what this OA plus OB minus OC is making with the x-axis. This is the direction that they wanted us to calculate. So what is the correct answer? Yeah, 1 minus this part divided by. So, any doubt in this problem, guys? Any doubt?
No, sir.
Yeah, so please note it down. Figure you have put it and whenever you guys note it down, please tell. Akib and Yasser, Martin, any doubt?
No.
Yeah, just revise. So vector is very important. Vector and calculus. So always keep revising these conclusions. So whenever you guys need to score down. Yeah, sir, done. So, yeah, guys. Whenever you guys need me to scroll down the screen, you guys.
Done, sir.
Done. Yeah, done, guys. Noted.
Yes, sir.
Martin and Yasir, Akib. Yeah. Okay, so this was about the resolution of vector question, and then we have yeah, projection. So projection, I'll talk about the angle between about dot product, the angle between vector, the angle x. Yeah, this question. The angles which a vector I, j, root k makes with x, y, z axis respectively. Right. So this question is based on direction cosines, right? We have a vector. So we have this vector. Let's say this is 1, 1 and 2. Okay. This part is given. So we know what is ax, we know what is ay, and we know what is az. And then they are asking that what is this angle with x-axis, what is the angle with y-axis, and what is the angle with z-axis. So we need to calculate alpha, beta, and gamma. Right. So first we need to calculate what is a. Okay. So a would be what, Akib? we have this vector A, and this is I plus j plus root 2k. So what would be the magnitude? Yeah, what would be the magnitude? Yes, the first topic of vector classes. What would be the magnitude? Root 6. Okay, so root of 1 square plus 1 square and square. So this would be root of 1 plus 1 plus 2. So root 4, which is, yeah, so this was root, right, yeah. So 2 would be the magnitude, right, guys? So now we know what is A. We know what is AX, we know what is AY, we know what is AZ. So what is cos alpha? Cos alpha is AX by A, which is 1 by 2. So for what value of cos theta, the value is 1 by 2? Yeah. For what angle of theta, your cos theta is half? Cos theta is half for which value? Which angle? Yes. Cos 60 is how much? One moment, guys. Yes. So 1 by 2. Yeah. So this is 1 by 2. So which means that theta is how much? 60. Right. Yes. So theta is there. Similarly, cos beta would be how much? This would be AY by A. So AY is again 1 by 2. So cos beta is half. So beta would be how much? 60. And lastly, cos gamma. So cos gamma is AZ by A, which is root 2 by 2. So this is root 2. And so what would be the angle, guys? For what value of theta your value is 1 by 45. So this is 45. So you see what are the angles? 60, 60 and 45. So 60 is understood. So you guys please note it down, and then we will do the next question and the question after that. So you guys please note it down.
Done, sir.
Done. Okay. Yeah. So Akib, Yasir, and Martin. What about you guys? Done. Akib and Martin. Done.
Yeah.
Yeah. Martin, what about you?
Yeah, I'm done.
Noted.
Yeah.
Let us go ahead and solve the next question. Okay, so this property that if a vector P making angles alpha, beta, and gamma respectively, right? So we have a vector and it is making an alpha angle, beta angle, and gamma angle, right? So we know that we have cos alpha, cos beta, and cos gamma, direction cosine. And you see that this is similar looking to some property that we have. Okay, yes. So we have these direction cosines, right? And this is a similar looking term, right? So we have one property which is similar looking. So what was the property? Yeah. Do you guys remember one property? So that is called the cosine law. So what is that property? Yeah. Cos square alpha plus cos square beta plus cos square gamma. Right. So this is resembling to this term. Right, guys? So what is the value? What is this value? Yeah, what is this value, guys? This we have already talked about, right? Just at the start. So this is one. Okay. So this is one, right? And how can we get sine square, sine square, sine square from these values? How can we get that? Just remember trigonometric quotient. So what is cos square in terms of sine square? Yes, what is cos square in terms of sine square? Any guess? Any yes. 1 minus sine square. Yes, correct. Yes. So I can write cos square as 1 minus sine square alpha. I can write cos square beta as 1 minus sine square beta. And then cos square gamma as 1 minus sine square gamma. So this is 1. And this is minus. So 1, 1, 1, right? This is 3 minus of sine square alpha plus sine square beta and then sine square. So this is 1. So this I take in the right hand side and this in the left hand side. So sine square alpha plus sine square beta plus sine square gamma would be how much? 3 minus 1, which is 2. So this would be the answer. This is clear. So this is the answer. Any doubt in this, guys?
No, sir.
Yeah, please note it down and then and you guys keep revising the lecture because that is very important. When I finish this and when I start the uh, motion in a straight line or motion in 1D, so we will use so many portion of this one. So that would be that's very important. So whenever you guys have finished
Done, sir.
done. Okay, so the next question you guys calculate and get the answer because that is a direct question. So question number 10. Guys, calculate and tell me the answer. So the direction cosine of vector here. Direction cosine is cos alpha, cos beta, and cos. Yeah. So these three values. Calculate and tell me the answer in chat box. So you guys have 3 to 5 minutes, right? But if you guys calculate faster than 1 minute, just calculate and tell me the answer. Yeah, who is calculating? A. So Yasir has got A. So this is
Sir, I
Yasir.
also got A.
Okay, Siddhika also got. So yeah, guys have got A. Yeah, majority is with A. Akib and Martin, what did you get? Yes, what did you guys get? Akib and Martin? 3. Oh, okay. So Akib is calculating. And Martin, did you get the answer?
I already.
You are also doing. So let me calculate and you guys check whether it is correct, right? So yeah. A is I plus 4j minus 5. So what is AX? AX is 2, right? AY is 4 and AZ is half 5, right? So minus 5. Okay. And then what do we have? Then we have A magnitude, which is what? Which is 2 square plus 4 square plus 5 square. So this would be 4, 16, and 25. So 45, right? So cos alpha is simply AX by, which is 2 by 45. Cos beta is 4 by 45, of course. And then cos gamma, which is minus 5 by. Yes, so Yasir and Sutika, absolutely correct answer. And yes, Akib and Martin, did you get the same answer?
Yeah.
So this was about the resolution of vector and direction. Okay. And yeah. Okay, you didn't get the answer. So where did you fumble? Okay, yeah. So what part? In which part did you? Okay, please correct that. And yeah, so if you have any doubt, Akif, you can ask. Oh, calculation. Yeah. So practice, practice. Okay. Okay, and then I can see that the rest of the questions are based on rating ensure that to have the result. This part. So this part is also about the resolution of vectors. Right, we have so this part, right? So three forces are acting on on a particle as shown in the figure. To have the resultant force only along the y direction, the magnitude of the minimum additional force is, right? So first we need to calculate, let's say that this is O, A, B, C. So the resultant would be how much? This would be OA plus OB plus OC, right? So to calculate OA, OB, OC, we have to resolve it first, right? So first, let us resolve OB. First, what we will do is that first we will calculate this part, and then we will see what is the other information. Okay. So first, we have to reach this part. So first, let us calculate OA. OA is this, and remember that it is making the angle with the vertical. But we have to make the angle with the horizontal. So this would be how much? Okay. This is 30, so this would be, yes, okay. This would be how much? 60. Absolutely correct. This is 60 degree. And now you tell me that what is OA. Magnitude is 1 Newton and angle is 60 degrees. What would be OA vector? Yes. What would be OA vector, Akif? OA vector, guys. Martin, OA vector.
Yeah.
Yeah, what would be OA vector? Magnitude is 1, angle is 60.
Okay. So cos 60.
Yeah. So 1 cos 60 I hat and plus 1 sin 60 t. This would be the OA vector, right? So cos 60 I hat plus sin 60 t. This is OA vector. And then what is OB vector? OB magnitude is 4 Newton. Angle is again 60. So 4 cos 60 minus I and plus 4 sine 60 and J. Right. This is the vertical and this is the horizontal one. So this was the OB. This is vertical and this is the horizontal. So minus of 4 cos 60 I hat and plus of 4 sine 60 J. And then we have OC. So OC is how much? OC is, this is the horizontal. For case of OC, this is the horizontal, right? So again, this is 30, so this would be 60. So this is 60 and this is 2 Newton. So I'm just directly writing. So 2 cos 60 I hat plus 2 sine 60 minus 2. So this would be 2 cos 60 I hat minus of 2 sine 60 hat. This is OC vector. Okay. Now we have calculated OA, OB, and OC. So just plug in the values and we will get the result. So the resultant would be how much? Cos 60 I plus sine 60 J minus 4 cos 60 I and plus 4 sine 60 J and then what? Plus 2 cos 60 I minus 2 sine 60 J. So this is the resultant. So cos 60 minus 4 cos 60 plus. So 3 minus cos 60 I. And then what? And then we have sine 60, 4 sine 60, so 5 minus 2. So plus 3 sine 60. So this would be how much? This would be minus of half I hat plus 3 root 3 by 2. Okay, this is the resultant. Understood? Is this clear to you guys? Yeah. Is this clear to you? Yes, guys. So is this clear to you? Akib, Martin, and Siddika and Yasir. Here.
Yes, sir.
Okay,
Yeah.
so yeah. So what we have calculated so far? We have calculated the resultant. Okay. So to have the resultant only along the y direction. So we have to have the resultant only in the y direction. So you see that this vector has a resultant. So this is in the x direction and this is in the y direction. Okay, so if I draw this vector, vector, my voice is lagging. Is my voice lagging, guys? Siddhika,
No, sir.
maybe your internet is not stable, actually. So maybe your internet is not stable. So you guys see that this is negative of x and this is positive of y. So this is which quadrant? Which quadrant it is? Yeah. So you see that this is negative of x, this is negative of x, and positive of y. So this resultant of all these vectors in this direction, right? So this is the resultant, and its vertical part is 3 root 3 by 2, and its horizontal part is minus of r, right? Is this clear to you? So this was this is the resultant, and the question what they have asked. So they have asked that to have the resultant only along the y direction, the magnitude of minimum additional force needed is, right. So you guys see that this has x part and y part. What I add in this vector so that I get the vector only in the y direction. So this is the equation, right? What I add in this vector so that I get the vector only in this direction. So this part survive and this part gets cancelled, right? The x part gets cancelled and I have only this part. So what would be, let me write, so geometrically or figuratively, this would be this part. So if I add this vector, if I add this vector, so this vector and this vector will cancel. And I will only have this part. So you guys tell me that what should I add here so that I get the vector only in this y direction. You guys think and tell me. So the question was this. Okay. The question was that three forces are acting. So these are the three forces. And to have the resultant force. So we calculated the resultant, right? And resultant force only along the y direction. The magnitude of the minimum additional force we get. So this is the resultant that we get. And what should we add so that this part gets cancelled? So yeah, what is the answer, guys? What I add in this vector so that I get only y component. Okay,
Yes, sir.
what should I add? So that I only get the y component. The x component gets cancelled. So what should I add? Yeah.
Plus x.
Yeah, plus
Plus x.
x
Plus x. X. Oh, plus I.
sec what? Y angle. Do we have any angle? Martin, Yasser, Satika. Yes, Martin, Yasser, and Satika. Any clue, any idea, any suggestion, any guess?
X by 2.
Yes, what should we add? So if I add 1 by 2i, right? What happens with this
Yeah.
vector?
X cancel.
Yeah, this part will get cancelled, right? And I will get only 3 root 3 by 2j, right? So if I add 1 by 2i, this part will get cancelled and I will have the vector only in the y direction. So answer is 1 by 2i. Right, and what is the magnitude of 1 by 2i? So this is 1 by 2, which is 0.5. Okay, magnitude is 0.5. So what is the answer? 0.5. So clear, guys?
Yes, sir.
Yes, clear? Or do you guys have any doubt? Yes, guys, clear or any doubt?
Yeah, clear. Sir.
Okay, so please note it down. Please note down the question as well as yeah. So in today's class, we only talked about the resolution of vectors. Okay, in the previous class, we solved the question of parallelograms law and addition and subtraction of it. And before that, we solved the Cartesian form of the vector. So the next class I will talk about dot and cross products. Then this vector will be, and then we will do the motion in the straight lines. First, I will start with distance displacement and average speed, average velocity. These kind of questions. So whenever you guys need me to scroll down, yes, completed guys. Yes, done.
Done. Sir.
Okay, what about rest of you guys? Yasir, Martin, and okay. Complete. What?